Hi everyone. So in this video, we'll be continuing the solutions to IOQM 5 markers like the mock test, and we'll discuss problem numbers 26 to 20. Oh, problem 26 to 30. So let's begin. Problem 26. So how many triples satisfy the following system? So one basic step, like you see that this is like symmetric sums. I don't know if symmetry is the right term actually, but like I think it's visible that if you sum all of this over, you get a plus b plus c equals to 0 basically, right? So now a to the power 4 minus b to the power 4 equals to a minus b into a plus b into a square plus b square. This should be equals to c, right? Like this equation. And a plus b can be written as minus c. So assume c is not equals to 0 for now. Then you'll get that minus a minus b times a square plus b square equals to 1. Or let's just do minus 1 here and like multiply by minus 1. So we know that a square plus b square is greater than 0. Right. Okay. Let's just assume that none of ABC is 0 for now. So then this will be greater than 0, right? This implies for this to be true, A minus B must be less than 0. Similarly, you'll get B minus C is less than 0 and C minus A is less than 0. So if you sum all over this, so you'll get 0 is less than 0, which is not possible. Okay. So now suppose C is equals to 0. Then the three equations reduce to A to the power 4 equals to B to the power 4, B to the power 4 equals to A, and minus A to the power 4 equals to B. This gives A equals to plus minus B. So let's see when A is equals to B. In this case, you get that B to the power 4 equals to B, which implies B is 0 or B is 1. The other two are like, what do you say? Uh, Complex solutions, but we are given that A, B, C are real numbers. So when B is 0, you'll get that A equals to B equals to C equals to 0. So, okay, this is one solution. When B equals to 1, A is also equals to 1, but this equation is not true. So let's now see when what happens when A equals to minus B. Then B to the power 4 equals to minus B. This implies B can be 0 or minus 1. The 0 case is already done. It will give you this solution. For B equals to minus 1, you'll have A equals to 1. And all the three equations are satisfied. So minus 1 comma 1 comma 0 is one solution. And similarly, you can get cyclic shifts of this. Basically, you'll get 0 minus 1 minus another solution and 1 0 minus 1 another solution. Like you can check C equals to 0 we did, B equals to 0 and A equals to 0. So you get four solutions like these three and 0 comma 0 comma 0. So the answer is 4. Okay, that was pretty quick and like I didn't really give much motivation. So I'll just go over the idea once more. Like the most obvious thing is to add all of these things. And once you add, you try to use this thing somewhere. So you factorize this like it's easily factorizable. And you see, oh, what happens with this? Like this thing is equals to minus 1. This thing is greater than 0. So this is less than 0. Now you use the same thing in other equation. Like whenever you have questions of these type, like you have uh, symmetric equations in A, B, and C, then you do stuff for one equation and write the similar stuff for other two equations and use all the three things obtained simultaneously. So this will give you a contradiction here. So this just rules out the cases when A, B, C are all not 0. So at least one of them must be 0. And that case is like easier to deal with. Okay. Okay, that was super quick. Let's move on to the next problem, problem 27. So in this problem, you see that there's a root x here, root y here, root xy here. And then I can write x and y as like some root x squared. So this looks like a nice squaring thing. So let's see. This is root x squared plus 2 root y squared minus 343 times root x plus 2 root y plus 2 times root x times 2 root y plus 2022 equals to 0. So I can combine this and this term to write root x plus 2 root y whole squared minus 343 times root x plus 2 root y plus 2022 equals to 0. Now, let like this is a quadratic in root x plus 2 root y, right? Equals to k. So this implies k square minus 343k plus 2022 is 0. Uh, Let me check the solutions of this equation. Like you can use it like solve it using quadratic formula. But okay. So this implies k minus 6 into k minus 337 is 0. So this means that root x plus 2 root y is either 6, or root x plus 2 root y is either 337. And you have to find integer solutions, right? So let's see. When we put y as, so see, like let's try to fix y and see how x looks like. So for x to be an integer, like root x equals to 6 minus 2 root y, right? So x is 6 minus 2 root y whole squared, which is 36 plus 4y minus 24 root y. So for x to be an integer, root y must be an integer, which implies y must be perfect square, right? And clearly, so see, if you take y equals to 1, y equals to 0, then x equals to 36. This works. Y equals to 1, then x can be 16. Y equals to 2, sorry, 2 squared, then x would be like 4. And if y equals to 3 squared, then x is 0. So you get 4 solutions here. Like now, and similarly, this thing, y should be a perfect square by similar logic as here. So when y is 0 squared, x is something like 337 squared. When y is 1 squared, x is equals to 335 squared. And this continues until like when y is like something 168 squared. 168 or 160? Okay, let's try 168. Then x would be 336 1 squared. And when y is 169 squared, x would be uh, yeah, x will not be defined. So only these solutions. So these are 169 solutions. So you have 169 plus 4 here. So total of 173 solutions. So n is 173, and you have to find GIF of n by 10, which is 17. So the answer is 17. So like the idea is like you see, oh, there are under roots and then this is under root squared. So you write that in the square format. And like 343 is a big number, so you take that common. And like completing the square is an obvious step. So now this becomes a quadratic. And then that is not the hard part. So just seeing that solves. Okay. Let's move on to the third question of this video. Problem number 28. In triangle ABC, L and K are the points of intersection of angle bisector of. Okay, I'll draw. Angle bisector of ABC. So this is L, and BAC. This is K. The segment KL is the bisector of angle AKC. Determine this. Okay, we have seen a question of similar flavor before, right? The first step, mark all the angles. So if this angle is alpha, this angle is alpha. If this angle is beta, this angle is beta. If this angle is delta, then this angle is delta. Like clearly L is the AX center of triangle ABK, right? Which means that AL bisects angle BAK externally. Which means if we extend this, this angle should also be alpha. Which means 3 alpha is 180 degrees. Which implies alpha is 60 degrees. So angle BAC is 120 degrees. Which means GIF of under root of this thing would be 10. So the answer is 10. Okay, that was a quick problem. I don't know why it's a 5 marker. It should be like 3 marker at most. Yeah, should have checked this before. Anyway, like mark all the angles. You just see that this is the external angle bisector. Use that property with the leftover point about which you have details. As simple as that. Okay, so let's move on to the next question. Oh, the next question is I think like uh very deserved 5 marker and like it's a good question. So one thing to notice is okay, I'll just read the statement first. So we have to find the maximum area of a semicircular disc inside a square of side 1 by root pi. Yeah. See, like you have to find area and you're given side of a square. Like that is just a bait. Like you can just take a unit square and then scale it by a factor of 1 by root pi. The area will be like just scaled by a factor of 1 by pi. So maybe there will be some like factor of pi in the answer and the examiner wanted to remove that factor. So they just took this some random constant. So we'll take a unit square. And obviously if the like a disk with largest area would be like this, then it wouldn't be like a 5 marker, right? So it's like something like trickish. So let's take a tilted disk. Uh, let's take a disk like this, which is tilted at an angle of theta. Now, if we take the center of this disk, let's say this point as O, and we take any random point on the disk, let's say P, then okay. Also, let's say the radius of the disk is R. Like we essentially want to calculate the radius. Then notice that what should be the condition for P to lie inside the square? Like if I consider this length, basically if I vary P over the disk, this length is varying, right? Right. So what I can do is I can take this OP and drop a perpendicular from O onto CD and see what this length is. Let's say this point is Q. Then OP plus OQ is OP is just like radius plus OQ is R sine theta. This should be less than equals to 1, right? Like how do I put this? Okay, this is basically like, okay. So yeah, so see, if you construct that like this length is R sine theta is fixed, and if you take R distance above this, then this point will obviously lie on the disk, right? And if this like this total distance R plus R sine theta is greater than equals to 1, then this point will be outside of the square, which is not good. So this is one condition. And similarly, we can do in this direction as well to get that R plus R cosine theta is less than equals to 1. So you have this condition, which just means that also I think you have one more condition on theta, right? Yeah. So okay, let's see that condition. Mm, yeah, let's see that condition later. Okay. So from this sine theta equation, you have that R is less than equals to 1 over 1 plus sine theta. And from the other equation, you have R is less than equals to 1 over 1 plus cosine theta. So overall, R is less than equals to minimum of 1 over 1 plus sine theta, comma 1 over 1 plus cosine theta. Right? When theta is in the range 0 to 45 degrees, then we know that cosine theta is greater than sine theta. So 1 plus cosine theta is greater than sine theta plus 1, which means 1 over 1 plus cosine theta is less than 1 over 1 plus sine theta. Right? So this implies R is less than equals to 1 over 1 plus cosine theta. Uh, yeah. And what is the maximum value of this thing? The maximum is obtained at theta equals to 45 degrees. In which case the value is 1 over 1 plus 1 by root 2, which is root 2 over. Oh, wait a second. Did I mess up somewhere? 1 by root 2 plus 1. Oh, yeah, no, this is okay. So this is root 2 over root 2 plus 1. Like this is maximum because you can check like at theta equals to 0, r is less than equals to 1 by 2. But this value is clearly larger than this. Also, you can see like cos theta is decreasing, which means this whole term is decreasing, which means this whole term is increasing. So this was for theta in 0 to 45. And you can check for theta in the range 45 to 90. You'll still get the same maximum value. In that case, like this will be the minimum. And the maximum of this thing will be at 45 only. Okay. So we get that r is less than equals to root 2 over root 2 plus 1. So obviously you can just say that r is root 2 over root 2 plus 1 is the maximum radius. If you want, you can formally show that this works indeed. And this works at like theta equals to 45 degrees. Like you'll have to like coordinate bash a bit and like find the tangency points and show that they lie inside the square. But we'll not do that here. And the vibe is clear, right? Like you get that this bound is there and you try to find what the maximum value of r can be, which you find using this idea. Like cos sine theta is greater than sine theta for some value. And yeah, I don't really know how to like put this in words, but like this is the main idea. You can see the explanation. Okay, so this is the R max. So max area would be pi r square 3 plus 2 root 2 over 2. So this would be pi times 3 minus 2 root 2 over 1. And since we scale the side by 1 by root pi, the area gets scaled by pi 1 by pi. So area after scaling is 3 minus 2 root 2. So P is 3, Q is minus 2, R is 2. I just wanted to make the answer extraction weird. So 9 minus 5 minus 2 plus 11 times 2, 9 plus 10 plus 22, which is 41. So the answer is 41. So see, the main idea here is like you try to see like which semicircular disk will have the maximum area, and you can define a disk by its radius and the angle it's inclined in the square at. And then you try to find the bounds, like what should be the condition for the disk to lie inside the square. Like try to find a strong enough condition, even if it's not that strong. Like this might not be the only condition, right? Like there might be stronger condition, but this is a good enough condition. It gives you what you want. And then it's just algebra. Okay. So that was it for the problem. Finally, the last problem of the mock, problem 30. Okay. So I have a diagram to this problem drawn. Uh, it was taking a lot of time. I didn't want to like waste the time while drawing the diagram. So I stopped and then draw. Also, this problem was like just meant so that nobody aces the exam. And like, I don't expect anyone to solve this. And I don't think I'll be able to solve this myself in a contest because the observations needed for this one are like insane. And this problem was just put in the concept in the contest because we were desperate for like a very hard problem. So the original solution to this problem was like you convert this problem into some China TST problem, which is solved using harmonics. And that was the only intended solution that we had at that time. And we're like, okay, eventually we'll find some solution, otherwise we'll just trick bash this. But now we do have an elementary solution, which I'll be presenting. But one thing is like these lengths BC, CA, AB are useless. The only thing which matters is once you use this length, uh, AB comes out to be equals to BD. That is the only useful thing. I don't think that it's like easy or like even normal at all to observe this thing. But okay, I'll begin with the solution with this, starting with this. Like you're given AB equals to BD and then the rest of the problem. Okay, since AB equals to BD and BD equals to BF, we get that ADF is a right angle triangle with AB as with AF as diameter. So we extend this thing and let it intersect the circle at X circle at D dash. Then since this angle is also 90, FD dash is the diameter, right? And since FE, this is IA, since FE is parallel to IAX, if we reflect E over this diameter, sorry, E over this parallel line, then we know that since this angle is 90 degrees, uh, and this being the midpoint, and so is this the midpoint. Like you can show by phantom points basically. Like this is not a formula, but by phantom points, it's easy to show that D dash is reflection of E in IAX, which means that XE equals to DX, D dash X, and D dash X is tangent to X circle. So let's just extend this line. And this point is basically like by if you know harmonics like projective geometry and all, like this point is very easy to show that it's concurrent. But apart from that, let me see if you can do POP. Well, so I cannot think of a solution using power of point and stuff, but there exists a simpler solution using symmedians to prove this concurrency. Basically, like AF and AE are tangents, which means AD is symmedian. In triangle DFE, which means FE is symmedian. In triangle DFD dash. And since D dash is DFD dash, this point should be like, let's say, some X dash. And since X dash is intersection of like tangents at D and D dash, Fx dash is also symmedian, which means Fex dash collinear. For this proof, you should definitely know the properties of symmedian. I don't think that's very important for IOQM. So please do not do that on the last of IOQM. Okay. So we got that this is the point X dash. Now, yeah. So see, this line is parallel to this line. Like this is AF, it's tangent to this X circle, right? So this angle is 90 degrees because IA is center. And similarly, similar logic, this angle is also 90. So these two lines are parallel, which means we get triangle ADB similar to triangle X dash D dash. So to find AK and KB, we just have to find some relation between XD dash and XX dash. But see, you have that this angle is 90, right? Like this angle is 90, so this angle is 90 degrees here. And you got that XE equals to XD dash equals to XX dash. Like X dash is reflection of D dash over X, which means that X is midpoint of D dash X dash. This implies K is midpoint of AB. Oh, excuse me. So now AB was 4. So K is midpoint. So this is 2 and this is 2. So we have to find GCD of AK square minus AK, which is 4 minus 2, 2. And BK square plus BK, which is 6. So this is 2. So the answer to this problem is 2. Yeah, like I really do not expect anyone to solve this problem in contest or even IOQM. Like this problem is like meant to be skipped in IOQM, I would say honestly. So yeah, that was it. That was all the solutions for IOQM MOOC. I hope you all enjoyed the mock and the solution analysis. So yep, thank you for watching everybody. Bye.